Hello. Today we consider the following problem. Let x1 and x2 be the positive real numbers, and for every integer n greater or equal to, let xn plus 1 is given by this expression. If x5 equals 43, what is the sum of digits of the largest prime factor of x6? Before we start solving this problem, I would recommend to stop the video and try to solve it yourself. Then please share your answer with us, and when you return, we will continue work together. Okay, first what we will do, we will try to find a relation between x6 and x5. We start with a given expression for xn plus 1, which is valid for n greater or equal to. We select n equal 5, which is greater than 2, and write x6 equal 1 plus this long product. Then we take n equal 4 and do the same for x5, which looks like this. Now we have this product of four numbers. We denote this product as y, and then we can write that y is equal x5 minus 1. Now return to x6, and we see that here there is exactly the same product, so we have here y. We rewrite x6 in this case using what we have for y, and we have x6 equal 1 plus x5 minus 1 times x5. This is a first step which we completed. Now we can find x6 using a given number for x5. x5 is equal 43. We plug in 43 here. So we have for x6 this expression. We cannot use calculator, but this is not a problem to find this by hand. And we have for x6 1807. Now we need to factorize this number to find the largest prime factor. Again, I repeat that we cannot use a calculator because on the Olympiads nobody can use such devices. So again, we will work calculating by hand, and in the beginning we will use so-called rule of thumb, which states that on the Olympiads the solution of the problems doesn't require lengthy complicated calculations. It is a practical rule. How we will use it? We will consider several initial prime factors: 2, 3, 5, 7, 11, 13, 17, 19, and so on. And we just test if one of these numbers is a divisor for 1807. In the beginning, the procedure is very simple. 2 is even number, this is odd number, so 2 is not a divisor. We exclude it. About 3. To be divisor of the number, 3 must be divisor of the sum of the digits of this number. We calculate sum of the digits. It is 9 plus 7 is 16. 16 cannot be divided over 3. 3 is excluded. 5. To be divisor, it's necessary to have here either 0 or 5. It is not so, so 5 is excluded. For 7 it is not so easy. And we just divide by hand this number over 7. I will use the rule which I learned in the school. It was a long time ago. You can use other rules. So let's go. 1807. Here I write 7. Then I move from left to right and look for number which can be divided over 7. Here is 18. So I have here 2. 2 times 7 is 14. Subtract from 18. I have 4 here. Borrow this 0. I have here 5. 35 minus 5. Take this 7. And here will be 8. To have here 56. I subtract. I have 1 as a remainder. So 7 is not a divisor. We repeat this procedure for 11. Then go 18 and 11, it is 1. 11, 7, take 0. Here is 6, 66, 4, 7, 4, 44, minus, again, 11 is not a divisor for this number. Next is 13. We should be patient a little. 13, again 1, 5, 0, here is 3, 39, 11, 7. Here is a little bit more difficult. So look, to have 7, we should write here 9. Let's verify 27, 9 plus 2, 11. So we have 117 here, and we have remainder equal 0. So 13 is a divisor for this number. We can write that 1807 equals 13 times 139. Now we need to analyze the number 139 and decide, is 139 a prime number or it can be factorized. We can do this using the rule of thumb, but I would like to show you more powerful method to decide if given number is a prime. I will illustrate this method in general case. We have integer n and we need to decide if it is a prime. First, what we do, we find square root of n. In our case, we find square root of 139, and this square root is between 11 and 12. Because 11 squared is 121, and 12 squared is 144. As a second step, we divide n over all primes between 2 and square root of n. In our case, we need to divide this number over 2, 3 till 11. And then we can make the following conclusion. If no divisor is found, then n is prime. Let's do this. We divide 139 over these prime numbers. The answer is negative, no divisor between them, and 139 is prime. Our number is a product of two primes. Largest is 139, and the sum of digits is 13. This is the answer in our problem. At this point, I would like to ask you if you like this rule and if you want to have a proof of this rule. Please leave a comment, and if you need the proof, I will record a special video with the proof of this rule. So the problem is solved. If your solution is different from that we obtained here, please share it with us and we will discuss it later. And let's help Dr. B on the work on the future videos. This help can be done with likes or dislikes, subscription for the channel, and comments, positive or negative. Thank you for your help.